What has somebody probably done? What in this story, what has somebody probably done? They boiled or cooked a potato. Did they boil it? They boiled it. Yep, there we go. They boiled a potato. Why is it now cooling down? Probably took it out of the water and just left it on a plate somewhere, right? It's cooling down. So I think it's really important that we understand that's the kind of thing that's going on, and we don't let the fact that there's a lot of words and a lot of math convince us that we just don't understand it at all. We'll get into the details here in a second. So we got the potato, it's cooling down, and there's 3 questions. Now, the last day and a half or so, we've done a lot of those find the particular solution of the differential equation, right? And in all those cases, excuse me, the wording has been really obvious. It said, find the particular solution of the differential equation using separation. I mean, it's super obvious. This set of questions has a task really similar to that. So my question to you is, can you read through A, B, and C, and can you decide which of those 3 questions, not in so many words, but is truly asking you to find the particular solution? That make sense? So I want you to pick it out, and once we figure out which one it is, we will do that one. So please read A, B, C, and all I really want you to do is figure out which one is asking me to find the particular solution. As you guys know, I'm a reader, and there's questions like this, or even more generic ones all the time. And I'll tell you what, if I had like $10 for every time someone just started separating variables when it didn't say anything about finding a particular solution, just because they saw a differential equation, they just started separating variables just because that's what they do, I'd be really rich. Like, people do it all the time. What that tells me is they're not actually reading the question. They're just seeing some symbols and be like, oh, I know what to do. Make sure you take the time to read the question. That's why we're doing what we're doing. Reading it over, saying, and this one, I'll tell you, this is probably the hardest example of being able to navigate this. Like, if you can navigate this, you probably could do any of it, as far as identifying when do I do this whole separate the variables, find a particular solution thing. Anyways, if it's tough, I get it. I get it. What A does.
Sure.
Okay, so everybody have any idea? A, B, or C, which one is asking you to find the particular solution? Which one do you think it is? A, B, or C? Okay. I'm getting a C and I'm getting an A. Okay, so Eden, you were really fast to say C. What words, I'll come up here and I'll mark this up. What words told you?
You're like, no, never mind. Hey.
What words told you that maybe that was it? Maybe you're wrong, but if you are wrong, let's not worry about it. Let's at least fix what's wrong, and maybe that'll be a learning experience for everybody. Or maybe you're right. We'll see.
It says find an expression for G of T, and then the next sentence is you need to find what G of 3 is. So, I mean, that's basing it off like G though.
Find it. So okay. So those are the. All I was asking is what words told you that that's what we were supposed to do. Did I represent you pretty well? Okay, let's hear Santi, Nick, right? You guys were both saying A, or was it Santi was saying A? So what words told you that A was the one where we're finding a particular solution?
You have to approximate the internal temperature at a certain time. So
Approximate the internal temperature at a certain time.
But you can't plug T into the equation that it gives to you, so that's why I assume you have to do the thing.
Gotcha.
Yeah.
Okay. Any other opinions? Or maybe some other phrases or words that you see that are like, oh, wait, this tells me something.
Number B.
Audrey, what do you think?
Well, I think it's A also, mostly because this is right in the equation. So that's like the particular, equation instead of because C is asking for what the temperature is instead of the particular solution.
Okay.
Maybe.
Okay. These are all good observations. Anybody else? I'd love to hear what you guys are seeing. Okay. Anything else? There's only eight? No, now there's 9 of you. No hiding. Anybody? Any other thoughts? Anybody like? Has anybody's opinion been changed in the last 3 minutes? What if it's both? It is only one question.
What if it's none of them?
There is one. I wasn't going to totally mess with you. Yeah. Okay. So, go ahead, Eden.
Okay, so you have A is writing. It already gives you dH over dt. So that is, you just need to plug in t equals 0, or I'm sorry, t equals 3. So that would give you the slope, and you just have slope tangent. Or like, what's it called?
We know the form you're talking about.
The formula.
Y minus y1.
Well, point slope.
You're
Point
not-
slope.
You're not solving for a c there.
But there's no
You can't plug in t into the equation.
Yeah, there's no input for t. You're right. There's just an h.
Oh, okay.
Yeah, so you couldn't. Yeah, you could not plug a 3 in for h because t is 3, right? Makes a difference for sure.
Shoot. What's G? That's the same thing.
So you both folks kind of zeroed in on those phrases. Carefully read what I've highlighted in red there.
Find an expression for G of t. We have.
And let me remind you what the solution to a differential equation is. The solution to a differential equation is an equation that if you differentiated it, you'd get that differential equation you had to begin with. Does that make sense? So the particular solution to a differential equation is basically the equation that you would have started with and done the derivative of to get the thing you started with.
Mm-hmm.
Basically reversing a derivative. Does that give you any more insight? Okay, so let's take a vote here. Nobody has said anything about B, and that's good news because B certainly did not ask you to find the particular solution of anything. You're all thinking, it's going to be B, isn't it? It's going to be B. It's not B. So it's either A or C. So we want to take a vote here? Or you have something? Go ahead. Yeah.
Well, if you say that it's the differential thing, then wouldn't it be C because G of t is the, like that would be what you differentiate to get to dg over dt?
Okay. I'm just going to let that hang out there. I'm not going to answer your question yet. She's asked a question I think is pertinent, right? Okay.
Well, I think it's because what's this about?
Okay, so let's take a vote here. Friendly vote. No one's going to be voted off the island or anything. How many of you will go in order here alphabetically? How many of you think that A is the one where we're going to separate the variables and find the particular solution, all that stuff? How many of you think it's A? How many of you think it's C?
I'm pretty confident.
Quite a few abstainers. You were the original C person. And now,
Like, I am lost now in the sea of knowing this.
My decision of talking.
okay, so if the letter, it's not snake. If the correct letter was the starting letter for a plant, it would be a cactus. It's C. C. So let's talk about why.
C as in
Snake, right? Yeah. So let's talk about why it is. So in A, it does say write an equation. And that's obviously important. It's telling you something you're supposed to be doing. But it says write an equation for the tangent line. Tangent line, right? So remember, if you've got some curve, a tangent line is going to look something like that, right? So a tangent line is going to be a reasonably good approximation for a curve, but it's not the curve unless the curve is a line, right? The tangent line is just going to be an approximating tool for the curve, but it is not the curve. So we are supposed to write an equation, but it's for the tangent line in A. And then you're right, we do use that equation to, bless you, to approximate. So this is what's really important for us to realize. The particular solution to a differential equation is the exact equation that if you differentiated it, you'd get what you started with. It's not an approximation. So that's an important thing to realize. And like I said, I thought the wording on this one, I was asking Jordan about this because I think this was from like a year or two ago off of an AP test. And I remember people were all upset. They're like, man, the wording is so tough. And I do think the wording on this is pretty tough. It's not nearly as obvious as some of the stuff we've done. When I say everyone was upset, if you ever this May, if you want to be like wildly entertained, just get on the what is it, Twitter? I think the
Yeah.
Twitter feed for after the AP tests.
Oh,
AP Calculus Twitter, like it's hilarious to watch how mad these kids are and blah blah blah.
I'll be tweeting them.
And what I love is I love going hanging out with you, and I'm like, oh man, how'd you guys do with the escalator problem? I saw a lot of people hated the escalator problem. And no, listen, last year was the escalator problem. People were like, what? Blah, blah, blah. They're so mad. All these little memes about escalators and things. And I was like, I go talk to my students. I was like, hey guys, how'd it go? They're like, oh, it was easy. It was a water tank question. I was like, okay, cool. Because I didn't know what it was either, right? All I know is people are upset about the escalator. So I just get on it just purely for entertainment value. Anyways, so the key phrase is actually, Eden, the one that you, at the very start, the one that you said, find an expression for g of t. That's actually really the key phrase. And I know you kind of backed off that a little bit, but that is the thing that would be telling us you need to do. You need to be finding a particular solution to a differential equation. So let's read all of C real quick, and then I want you guys to try to find an expression for g of t, and then we'll deal with the t equals 3 temperature. So it says for t greater than 10, an alternate model. So listen, the AP folks will do this to you a lot. They'll say, hey, there's this dHdt thing and blah, blah, blah. You do some things with that. And then in a later part, they'll say, you know what? Some other scientist came up with a better way, or some student noticed some pattern, or for t greater than 10, or less than 10, an alternate model for the internal temperature is given by G, and they give you this other set of information. So you have to kind of switch gears a little bit. That makes sense? They'll do that to you sometimes, not all the time. So we have this new model, and the new model satisfies this differential equation where g of t is measured in degrees Celsius and g of 0 equals 91. So just like before, find an expression for g of t. So this right here is code for find the particular solution. It's probably the toughest example of that wording, okay? That's why I'm showing it to you, so that if you can maybe figure this one out, the other ones be hopefully easier. So you guys, now I don't think the mechanics of this are all that hard compared to what you've been doing. It's the wording. That's why I wanted to do this. So if you would, now that you know what to do with this, would you guys please try to find that expression for g of t? Ready, set, go. So here's what I would say. If I was going to separate my variables, I'd go with this.
This is a constant. Oh wait, the whole thing is a constant. Bad notation there.
So you might have been tempted to bring the -1 over. Remember that one yesterday where I think it was a 6, and you all brought the 6 over with the x or the y or whatever it was, and I said, you know what? Just leave the 6 over there with the x. It was with the y, yeah. Leave the 6 over there with the x's because you know you're just going to have to take it back over later anyways. I feel the same way about that minus sign. I'm just going to leave that minus sign over there on the right. I'm taking the g minus 27 2/3 over to the left. So again, if I were doing this one, I'd at least have a point here, right? I've correctly separated the variables out. So anyway, I didn't want to do that. There we go. I would say as it's currently written here, so it'd be dg over g minus 27 to the 2/3 equals -1 dt. I would say as that is currently written, I would want to flip the denominator up to be able to handle that antiderivative for the left side. So I'd get this antiderivative of g minus 27 to the -2/3 times dg equals the antiderivative of -1 dt. So we were discussing a little bit about why the left side is not natural log, why it doesn't lead to a natural log. What would be the one thing that we could erase, like if we wanted to change this question? What would be the one thing we'd need to erase to turn the left side to where it would actually lead to a natural log?
To the 2, yeah.
The 2/3, right? If it was to the first, then we would be heading right for a natural log for sure. But that 2/3 messes all that thinking up.
Yeah.
We're not going to do that. But anyways. Okay, so I'm looking. Most of you guys are getting on towards figuring out what the C would be, it looks like. Yeah, okay. This is this, you know what, believe it or not, This is not calculator active.
That's brutal.
I don't think this, I'm quite sure this is not calculator. Well, so far, I don't know, what have you really needed a calculator?
To type in.
I don't know, do we, I'm pretty sure it's not calculator active. I think this was like number 5, and number 5 is always not calculator.
Do you have the answer right now?
Not off the top of my head.
Oh,
We'll figure it out in a
Oh, so
second.
you
Yes,
put
ma'am.
the C over here.
never mind.
All right.
Yeah.
Oh, I think this is doable. 91 minus 27.
It is doable, it's just.
64.
I don't want it to be doable.
Cube root of 64 squared. Yeah, it's doable. I mean, I agree, the calculator makes it easier, but it's doable. Okay, let me see if I can catch up to you guys. So your antiderivative on the left would be g minus 27 to the 1/3 divided by 1/3 would actually be times 3 equals negative t plus c. You guys okay with that? Audrey?
You might have said this, but why does the negative go away?
The negative. Which negative?
For like negative 2/3, wouldn't it be negative 3g minus 27 to the 1/3?
No, so when you do your power rule for antiderivatives, you add 1 to the old exponent, and negative 2/3 plus 1 is positive 1/3,
That makes sense, alright.
and of course leading you to a positive 3 on the front. Does that work?
Yeah.
Okay. All right, so as you guys know from yesterday, perhaps, I am a fan of plugging my initial condition in immediately. So I'm going to say, based on g of 0 being 91, I'm going to write 3 times 91 minus 27 to the 1/3 equals negative 0 plus c, right? I've plugged in my g of 0 equals 91. All that really means is when t is 0, the temperature of the potato is 91, which you already knew from the description above. All right, so this is where the arithmetic ensues. 91 minus 27 is 64. And
You did.
cube root of 64 is 4. Did you guys get 12?
Uh-oh.
Now, if we timed it differently, this could still work out, Nick. So let's see if that works out. So it'd be 3 times g minus 27 to the 1/3 equals negative t plus 12. And what I need to do now is try to solve for g. So I divide everything through by 3. That would give me g minus 27 to the 1/3 equals negative 1/3 t plus 4. Is it working out better?
Much better.
Okay. How do I get rid of the to the 1/3 power?
What do you cube it?
Cube both sides. Not cube root.
Oh,
Cube. Yeah, to the 3rd.
Ah, yeah.
Yeah. So if I do that, I'll come back over here. That would give me g minus 27 equals negative 1/3 t plus 4 quantity cubed. Whew! And finally, all we got to do is add 27. So the temperature of the potato is equal to negative 1/3 t plus 4 to the 3rd plus 27. What do you think? Okay, so at this point, here's what we have done. I'll highlight it for you. We have done this. That thing that Eden pointed out at the very start. Find an expression for g of t, aka find the particular solution for g of t based on the initial condition and the differential equation. So then, how do we answer the final question here? Based on this model, what is the internal temperature of the potato at t equals 3? What do we do? Plug it in, right? This finishes pretty smoothly. We'd say g of 3, gosh, that'd be what? 54, right? You get 3 cubed is 27 plus 27 is 54. 54 degrees Celsius, I guess it would be. Okay. So this, again, I definitely believe in letting you know kind of the expectations. This would be for sure on the upper end because this was a hard question to even get into,
Yes.
right? Because we had to really have some discussion about what even does this question want me to do. After a while, we get to I need to find the particular solution, and then you still got to do it, and that in and of itself is not always easy. How'd you guys do once you realized it was a particular solution, separate the variables thing?
Oh,
Um,
handy.
I hope that went okay for you.
No, I was scared for a second.
I
when you
just
said
didn't know when to
12, but-
plug in. When does it see? Like, when do you?
As soon as I've done my antiderivatives, I do it then. I don't wait. I don't mess around. That's just me. Other people have different opinions, and I can respect that. But for me, I'm going to plug in right away.
Yeah, you did.
Could you put the C on the left side?
You could. It's not customary. You're going to see me do it the other way every time. But you for sure could. Should lead you to the exact same answer. No problem.
So this is just for like technicality. So if you put D of G but lowercase g, would you lose points for that?
You probably should, but you won't.
Okay.
Well, lowercase g, capital G, they're different, right?
Yeah.
The only time when you for sure would is if both of those were involved in a question
Oh.
and you picked the wrong one. But that'd be rare, if ever,
Okay.
that would be the case. Yeah. Well, let's do this. We've got about 5-6 minutes left, and I want to do one of these other parts just to contrast what we did with C. I'd like to do A, and when I see you guys again next week, we'll do B, and I got another really good one kind of like this. So if you guys would take a look at A. A says write an equation for the line tangent to the graph of H. We're back to that original differential equation model. Use this equation to approximate the internal temperature of the potato at time t equals 3. So we're still talking about t equals 3, but we're using this whole other model, and we're using a tangent line equation. So for finding the equation of a tangent line, what are the two things that we have to have?
Point of tangency.
Yeah, point of tangency, slope of tangent line. Does anybody have any idea what our point of tangency would be?
0, 91.
Yay. Point of tangency would be at 0, 91, right? That's t equals 0, h equals 91, right? Because it says write an equation for the graph of h at t equals 0. That's our point of tangency. Okay, so then we need to find the slope of the tangent line. What do we have to help us with that? Isn't that the slope of h?
Yeah.
dh dt. Okay. So then I want to know, this is where the notation can be a little tricky. I want to know dh dt at my point of tangency, so that would be at t equals 0. What's the issue? There's no input for t, but there is an input for, so when t is 0, h is 91. Make sense? So I'm going to say at t equals 0, dh dt equals negative 1/4 times 91 minus 27. Right, so t equals 0 and h equals 91 go together. So when t equals 0, h equals 91. So let's see here. The 91 minus 27 we already know is 64, and negative 1/4 of that is negative 16. Negative 16 for our slope. So that is my slope of the tangent line. Any suggestions on what the equation of the tangent line should look like?
H minus 91 equals negative 16 t.
T minus 0 or just t? Sure. Was anybody thinking using y's and x's?
No.
You're welcome to do that too, if you wanted to. I think what Santi has said is very contextual and makes a lot of sense. But if you wrote y minus 91 equals negative 16 times x minus 0, the t is the input, the x is the input, y is the output, h is the output. I mean, I think we can go either way. I do like Santi's, so I'll just leave it like that, but just know the y's and x's would be fine too. Okay, so we want to know what is the approximation for the internal temperature of the potato at t equals 3. What do? Plug in a 3 into what?
T.
In which equation?
Differential.
In the tangent line. Yeah, in the tangent line.
Oh my goodness.
So h minus 91 equals negative 16 times 3. So that's negative 48 plus 91. I got 43. Okay. So h equals 43. That's my approximation for the internal temperature of the potate.
No, wait, I take that back.
Yeah. What do you guys think about A?
Oh, that was not too bad.
Do you see how someone who is just rushing through the test could accidentally do what we did in C for A.
Oh, I
I
definitely.
was about to do it.
I definitely
So
No, you told me that.
as we get ready to leave here in just a second, I want to give you like a helpful hint, hopefully. Let's fast forward till May. Let's say you're doing the AP test, and let's say there's some question like this, and you start in on A, and A is like what A is, right? But you accidentally start doing C type work in A just because that's a habit or something, or you didn't really read the question, right? You're tired, blah, 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 right? Let's say that that's what you do. Here's what you do. Halfway through, you realize, oh my gosh, this work should go with C. So all you do is you finish what you're doing, you answer C, and you circle it, and you say, this should go for answer for question C. And you go down to the space for C, and you answer question A, and you say, this should be the answer for A. Whatever you do, don't just start erasing things and crossing things out. Like, as a reader, they will definitely, if you circle it or whatever, you make this big deal and say, this work and this answer should go with A, and this work and this answer should go with C. Please switch them for me. They'll switch them for you. Okay? So that's just a time saver. I would do the same thing on one of our tests. As long as you tell me,
Oh.
I just realized I messed up. This should go down here and this should go up here. We're good. Please don't scratch it out. Please don't erase it. Just switch it, right? And we'll be good.
They don't make you use a pen, right? I think some of the-
No, definitely pencil. Definitely pencil. So guys, so obviously we didn't do B. You can tell that if we had another like 15 minutes, we probably would have time to do B,
Oh, brutal.
right? But we don't. So we'll hit B. We'll try to hit B on next week. And then, like I said, I have one more really, really good question like this for you, and it's based on a trash dump. It's
I
awesome.
love the dump.
It's a trash dump question, and it's fantastic. So have a great day. Please, 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 please drive safe.